Good morning everyone. Today our topic is fluid mechanics. We know how to improve in fluid mechanism. Okay? In fluid mechanics we study the overall things, that is syllabus is fluid mechanics overview and characteristics of fluids, measure of fluids mass and weights, viscosity, okay, compressibility, vapor pressure and surface tension. Okay? Next. Let us see fluid mechanics overviews. Fluid, what do you mean by fluid and what do you mean by mechanics? Fluid is divided into two types. One is gas forms, another one is liquid forms. Gas means what? Air, helium, argon, etc. Okay? Then liquid means water, oil, alcohol, something. Then mechanics means statistics and dynamics. Statistics means what? Statistics means stability, pressure, buoyancy. Okay. Dynamic means laminar, compressible. Okay. Compressible, incompressible, turbulent, steady, unsteady, viscous, invisible. Okay, inviscous. Then let us see surface tension, compressibility, density, viscosity, vapor pressure. Okay, these are things we will study. Then let us move to characteristics of fluid mechanics. Okay, characteristics means it's a gas or liquid state. Then large molecular spacing relative to a solid. Then weak intermolecular cohesive forces. Then cannot resist a shear stress in a stationary state. Then will take the shape of its container. Then generally consider a continuum viscosity. Then viscosity distinguish different types of fluids. What is density? Measure of fluid. How can we measure the fluid? Mass and weight. Okay? Then density. Density means what? Mass per unit volume. Okay? Mass means density equal to m by v. Okay? M for mass, v for volume. Let us see. M for mass, v for volume. Okay? Different fluids can vary greatly in density. Liquids densities do not vary much with pressure and temperature. Gas densities can vary quite a bit with pressure and temperature. Density of water at 4 degrees centigrade 1000 kilogram per meter cube. Density of air at 4 degrees centigrade 1.20 kilogram per meter cube. Okay? Specific volume 1 per density, specific volume. Alternatively, specific volume means Q equal to 1 by density. Okay? Let us see specific weight. How can we measure specific weight? Specific weight of fluid is its weight per unit volume. Okay? Specific weight equal to, this is what? Density in, this is what? Gravity. Okay? G for gravity, this symbol for density. Specific weight characterizes the weight of the fluid system. Then specific weight of the water at 4 degrees centigrade 9.80 kilonewton per meter cube. Okay? Then specific weight for air at 4 degrees centigrade 11.9 Newton per meter cube. Do you understand? Okay, let us move. Measure of fluids, mass and weight, specific gravity. In specific gravity, how can you measure? Okay. The specific gravity of fluid is the ratio of the density of the fluid to the density of the water at 4 degrees centigrade. Okay. Specific gravity of fluid is the ratio of the density of the fluid to the density of the water at 4 degrees centigrade. Gases have low specific gravities. Okay, gases have low specific gravities. A liquid such as a mercury has a high specific gravity, that is 13.2. Okay, the ratio is unitless. In specific gravity, the ratio is unitless. Density of water at 4 degrees centigrade in specific gravity is 1000 kilogram per meter cube. Viscosity. Viscosity we will discuss later. Okay. See, surface tension. What is surface tension? At the interface between a liquid and a gas, or two instable liquids, forces develop forming a analogous skin or membrane stretched over the fluid mass which can support weight. Okay? The skin is due to an imbalance of cohesive forces. The interior of the fluid is balanced as the molecules of the light fluid are attracting each other, while on the interface there is a net inward pulling forces. Okay, surface tension is the intensity of the molecular attraction for a unit length along any line in the surface. Okay. Surface tension is the property of the liquid type. Surface tension is the property of liquid type. The temperature and the other fluids at the interface. Okay. This member can be broken. Okay. This member can be broken with a surfactant which reduces the surface tension. Okay. See, surface tension, liquid drop. Okay, surface tension, liquid drop. The pressure inside a drop of the fluid can be calculated using a free body diagram. Okay, how real fluid drop mathematically model. See, R here. R is the radius of the droplet. Okay, this side is the surface tension. This symbol is the surface tension. Delta P is the pressure difference between the inside and outside pressure. Okay, the force developed around the edge due to surface tension along the line. So F surface is equal to 2 phi r, this omega. Okay, applied to circumference. This force is balanced by the pressure difference delta P. F pressure is equal to delta P pi r square applied to area. Okay. Then again I will repeat. Okay. If any doubt comes, then ask me. I will explain you.